We are live.
Thank you. Hello, everybody. Good morning, good afternoon, and good evening, depending on your location. A very warm welcome to you all today to this Microsoft Fabric Thursdays Expert Series 2025 by Uttar Pradesh Power BI Club. I'm absolutely thrilled to see you folks here today and talk about AI driven rate limiting for secure scalable cloud APIs. My name is Rehana Sultana Khan, and I have spent 2 decades in the tech industry gaining good exposure to cloud infrastructure and artificial intelligence. From building patentable AI solutions to developing security solutions for compliance, I have a broad range of exposure and have seen firsthand how right technology choices can transform business outcomes. Today, we are going on a comprehensive journey through one of the most critical aspects of the modern cloud architecture. We'll spend next hour or so diving deep into AI-driven rate limiting, not just as highlights, but a practical roadmap for you to take back to your organizations. Now, let me talk about one of few fundamentals, or rather, let me go through the agenda first. We'll start with the fundamentals as to why rate limiting matters and where traditional rate limiting approaches fail. Then we'll dive into technical architecture, the journey from the data collection to model deployment with practical examples. We'll explore real world case studies with detailed analysis. We will also discuss implementation strategy you can start using like tomorrow. You are we have actually allocated specific time for each section, and I will try to ensure that we go in depth in each of the topic that it deserves. Now, moving on to the one that I actually started telling just a while back, the importance of rate limiting. Before that, let me start with fundamentals. The proper definition of API is application programming interface, an interface that accepts requests and returns responses as per the request. These API forms the backbone of our digital ecosystem, or should I say, backbones of our daily digital lives. From messaging to social media to online payments to e-commerce, everything runs on them. What's more important is when it comes to our PI or PII, personally identifiable data, the security aspect is of paramount importance. These include your medical record details in your health, which will be in as part of your health records, or even your credit card or bank details, which are part of your bank. We all know the damages caused by stolen this kind of stolen data, which is done to organizations or even individuals like us. What's more, you are interacting with complex ecosystem of APIs. In fact, modern microarchitectures might involve hundreds of APIs calls for a single user interaction. Rate limiting is the first line of defense for APIs. But as you all know, without an effective rate limiting in place, all these APIs can quickly become targets for abuse, either through a brute force attack that can crash services, causing denial of service, or sneaky, stealthy smart bots that can inflate costs or even steal important data. Let us share a real example from my experience. One of the companies that I worked had a data breach. As a company which can have sensitive information of user stored in database, this attack not only impacted my org but several of our customers and their end users. With some quick resolution of having data scrubbed in place, which led to mitigation of further damage while bringing up a much robust architecture happened as part of the larger org level security hardening. While this is not rate limiting issue, It showcases the much larger security threats out there, creating significant security risks on a daily basis. Let's talk about how traditional rate limiting works. It basically tracks the number of requests per second using a limit, and anything beyond that number of requested is not accepted. Now, does this protect the API to an extent? Well, yes, to ensure the services don't go down while trying to cater to requests, but in the world of evolved and sophisticated attacks, this does not do much. The consequences of inadequate rate limiting are threefold. One of the first one is security risks like brute force attacks, credential stuff, API scraping, or performance issues, which includes conditions like severe service degradation, cascading failures, complete outages, or financial impact such as exorbitant cloud costs from unnecessary auto scaling, which primarily used to scale to cater to fake users, which might keep nodes up and more nodes might get spun up based on fake increase in the user requests. While traditional rate limiting protects systems by ensuring fair use and maintains reliability, especially during sudden spikes in demand, they still do not protect from much sophisticated attacks as we just discussed. Let's and here's the key insight I want you to think about. It's not just about defense, it's about having reliability, keeping cost under control, and ensuring an awesome user experience, which only helps growing the business further. Now, talking about static thresholds, let me talk a little more about static thresholds. Traditionally, rate limiting relies on static thresholds with simple rules like n number of requests per minute, let's say 1,000. This approach made sense in simpler times when we had predictable traffic patterns and controlled environments. But today, one size fits all limits do not work well in dynamic environments. Let me break down exactly why static thresholds fail. First, they lack context. For example, a static system cannot distinguish between a legitimate customer search during a flash sale versus a brute force bot attack. It cannot identify a scraping bot harvesting your data while keeping under your static rate limit. Secondly, they they create business friction. Imagine you're running a promotional campaign and your estimate traffic surges by 300%. A static system must mistake that as an attack, blocking real users and hurting revenue and growth of the company. I have seen this happen repeatedly. One e-commerce giant during a Diwali sale had their registration API blocking genuine customers because their static threshold was set too low. This lost significant revenue, but they could manually adjust the limits because before they could manually adjust the limits. Thirdly, they are operational expense. Every time you have a new feature launch or marketing campaign, someone has to either manually analyze and adjust the thresholds. It's a constant game of catch up. Even if the rate is configurable on the fly, it still involves some work to be done to help the search. Needless to say, it might actually open doors to brute force attacks if you're increasing the rate limit. Now that's a big problem. And how do we fix it? The answer lies in making rate limiting intelligent and adaptive. The fundamental shift we need to make is from rule based to behavioral based systems with multiple aspects and multiple configurable inputs. Instead of asking how many requests, we need to ask what is the behavior between these requests. Let me talk about some research insights. Oh, let's look at the data that proves intelligent rate limiting works. Studies show that AI-powered adaptive rate limiting improves detection accuracy dramatically. The research across multiple client configurations show consistent results, as in 96.8 accuracy in distinguishing normal versus malicious attack, and 68.7 reduction in false positives compared to static methods. But what do these numbers actually mean in practice is out for the 96.8% accuracy means that out of every 100 API, the system correctly identified 968 as either legitimate or malicious correctly. And that 68.7% reduction in false positive means dramatically fewer frustrated legitimate users. AI learns from real data, real time behavior, adapting to evolving patterns, ensuring that legitimate users get access and stay happy while attackers are blocked. Now, let's look at the AI driven framework. How does an AI rate limiting system look like? At its core, it's continuously learning from incoming traffic and dynamically adjusts its thresholds. Think of it as a smart security guard who learns everyone's normal patterns and can instantly spot when something is wrong. The framework has three characteristics: real time decision making. It makes real time, that means it makes real time decisions using machine learning models with latency under milliseconds. Behavioral understanding. It applies behavioral learning to track long term user trends across sessions and days. Cloud native design. It scales effortlessly across multiple environments from AWS to Azure and even GCP. It's not about blocking. It's about balancing performance and protection intelligently while ensuring business runs as usual without disruptions and high level of security. This goal is maximum security with minimum disruptions to legitimate users. Let me explain this with a powerful analogy that everybody can relate to. The concept is like this. Think of your API as a modern bank. A well-run bank serves customers efficiently, gives priority to premium customers, manages cash flow during peak hours, and prevents fraud, all while keeping legitimate customers happy. Now let's see how different API attacks might look like in a bank. Brute force attackers are like people trying hundreds of different PIN codes at an ATM. They are easy to spot because of their natural speed and reputation. DDoS attacks are like organizing thousands of people to stand in line for trivial transactions. They are not there for to actually bank, but to prevent real customers from accessing services. API scraping bots are like somebody who's slowly visiting every branch, carefully noting security layouts, employee schedules, security protocols, and they look like normal customers, but they are gathering intelligence. Credential stuffing is like thieves trying thousands of stolen credit card numbers to find active accounts. And another one is resource exhaustion attacks, are like someone making thousands of small withdrawals to drain the bank's cash reserves. Static rate limiting is like a bank that simply closes its doors after seeing like 100 customers, turning away both legitimate clients and fraudsters equally after the threshold. Now let us look at AI rate limiting. AI rate limiting is like having an intelligent banking security system that can, say for brute force attacks, type of attacks, spots the pin gestures after three failed attempts and temporarily block the card. For DDoS attacks like attack, identify the fake queue and open pop-up counters for genuine customers so that the customers can be catered to with their requests. For API scraping bots, analogy of branch mapper, detect the person and alert the security to monitor their activity and ensuring security protocols are up to date and not necessarily visible to public and or accessible to the public. For credential stuffing sort of attack of stolen card, recognize the stolen card and automatically flag suspicious transactions. And for resource exhaustion attacks, manage cash flow by limiting large withdrawals during high demand periods while maintaining service for regular transactions. The progressive response in banking terms will be a gentle slowdown, asking for additional ID verification, more stricter limits, temporarily restrict transaction amounts, and then hard blocks is like while include freezing the account and alerting the authorities. Customer segmentation naturally exists. We'll talk about user segmentation in a bit. Uh, Premium customers have higher withdrawal limits, having to use and also having to use private banking lanes. Regular customers have standard limits on services, and new and unverified customers have lower initial threshold, which will gradually increase. The smart banking systems maintains service for legitimate customers while adapting its security response based on specific threat pattern and customer value. Now, let's roll up our sleeves and get into technical details. This is where magic happens. Let's look at the data collection layer. There are multiple layers that we will talk about. One of them is data collection layers. You will get to know about other layers in the next slides. Looking at the data collection layer, everything starts with data. You can't build intelligence without high quality data. Data is used to identify features and create models. The system monitors over 14 traffic attributes from request frequency and session duration to IP reputation and geolocation. Let me give you some specific examples of what is collected. Temporal patterns like request timestamps, inter-request timing, which can help detect humans from bots. Basically, timing between the requests from the same user is detected and is identified whether it is humanly possible to make such timely requests. Geographic content like source country, city, or data center flags. And if this is different for the same user within a small amount of time. Example is a person who is accessing a bank account details in India in suddenly 2 hours cannot access the same account details somewhere from Europe. And talking about the another signal is behavioral signals like user agent patterns. API endpoint sequences to detect if it looks natural human-like or bot-like, which collects data. Human search for products, look for a specific one or another and then add to cart. Unlike bots, what they try to do is just, since they are here to collect data, they try to just keep searching for different types of products. And next one that we can look at is security indicators like IP reputation scores, known as bot signatures, to detect any suspiciously new IP addresses, which makes them doubtful source or user. Business context, like user tier. historical spending patterns to identify if this user is actual user or a hacked account. This gives us a 360-degree view of user behavior. High quality, timely data feeds the AI models and ensures smarter decisions. Now let's move on to feature engineering. This is where we transform raw data into intelligent signals. Raw data is transformed into 27 engineered features, including burst frequency ratios, entropy scores, and request error diversity. Let me explain what some of this actually means. Burst frequency ratios are the measurement of how often the user sends requests in a quick and sudden bursts versus steady streams. Sudden bursts are not natural and sometimes not possible when the end user is human. Entropy scores quantify the randomness in request patterns. That is, users often have highly random behavior which might qualify them as attackers. And the next one that we can look at as part of this engineered feature is request error diversity. Is to track how many different types of errors are user triggers. Same type of errors are getting triggered, that means it is very likely a bot. These steps helps the model understand subtle request anomalies that raw metrics simply can't reveal. Moving on to model selection and training. Now, model selection and training, after experiencing uh, now during model selection and training, after experimenting with several algorithms, it has been found that decision tree ensembles, specifically random forest and XGBoost, offer the best mix of accuracy and interpretability. Let me dive deeper into why these two algorithms are particularly well suited for API security. Interpretability refers to the ability to understand and explain why an AI model makes specific decisions in human understandable terms. This is just for you to understand what interpretability means. Now, getting back to the algorithms, uh, let us look at few algorithms before looking at random forest and XGBoost. Single decision tree. For those of you who know flowcharts, this is a simple flowchart algorithm. A simple binary flowchart goes something like: is the request rate above 100 per minute? If else, block. If not, continue. Or if the IP from a suspicious country. If yes, block. If not, continue. It's straightforward but too rigid, like having one security guard who can follow only basic rules or basic script. Log Logistic regression. This is like a simple scoring system. A high request frequency gets 5 points. A suspicious geolocation of the users could get 3 points. A trusted user history would get -4 points, basically reducing those points. Sudden location change might bump up those points to 15. So if the total score crosses a threshold, block the request. And if it's simple but misses complex patterns and nuances, which we will see further. Now, here's why we choose advanced approach. Random forest. This is a democratic decision maker where each decision is made independently of the other decision makers, and there are multiple decision makers which create the random forest. So think of this random forest as a committee of multiple security experts where each expert specializes in different aspects Some watch request patterns, whereas others study geographic data. They get they each get different training scenario. They all vote on each decision without the influence of others' decision or output of their decision. The majority vote wins. This approach is a lot more powerful because it is built on diversity, which highlights multiple independent perspectives, preventing any bias from dominating. This is a collective decision here, which means the group is smarter than any single expert, and there is natural overfitting protection from the fact that data variety prevents memorizing specific cases and influence from previous decisions. Now, moving on to XGBoost, when we talk about random forest, we are talking about a bunch of experts which are working independently. XGBoost is like an experienced detective who learns from every case, and it is also observed that a single decision tree is like a one detective with a basic checklist. However, XGBoost is like a team of specialized detectives working together on a tough case. So the flow is like this. Let me get back to the detective's analogy. In this, the first detective makes the initial assessment based on obvious clues. The second detective comes in, but instead of starting from the scratch, they focus specifically on the mistakes and missed clues from the first detective and do not touch the previous detective's clues. The third detective learns from both previous detectives, paying extra attention to whatever is unexplained or undetected. This continues with each new detective specializing in correcting the collective errors of who came before and analyzing data which was not analyzed or which was not looked at, or analyzing a situation or a pattern which was missed by the previous detective. This approach excels at one, sequential learning, which means each detective in XGBoost closes gap left by previous ones. Secondly, concentration is on focused improvement, where the detective later is focused on previously overlooked patterns. Then, then comes collective intelligence, where the team together understands that any single detective would miss and have adaptive strategy. They adjust their approach based on what's going on. Practical implementation insights. In production, a blended approach is utilized where XGBoost is used for high confidence real-time blocking decisions, and random forest is used for behavioral pattern analysis and long-term user profiling. This combined ensemble is used in critical security decisions which require maximum accuracy. Now let's look at why do we use this model. There are three key reasons. With respect to performance, these models achieve 97.5 accuracy on benchmark datasets. With respect to interpretability is vital, especially when you are explaining model behavior to security teams or auditors, and this combination provides a good interpretability. And robustness. They handle missing data well and are well prone to overfitting. Are less prone to overfitting. The bottom line is that the age-old rules are not being used, that the attackers can easily bypass. We are using intelligent systems that learn, adapt, and make nuanced and data-driven decisions to protect your API while keeping legitimate users very happy. And because traffic patterns evolve, the models are retrained continuously with fresh data, keeping them up to date on an ongoing security threats as well. Model will typically get retrained weekly or when significant pattern drift is detected. Now, let's talk about the deployment strategy. How do we make this work in real world? For real world usability, deployment must be seamless. This has been tested across AWS, Azure, and Google Cloud, integrating with gateways like Azure API Management, Kong, and APG. The deployment architectures follow three key principles. The solution prioritizes minimum latency, where the system performs real-time inference with, with latency under a few milliseconds. High availability, showcasing auto-scaling clusters that can handle sudden traffic bursts effortlessly, and easy integration when plugin based architecture works with existing API gateways. Let me talk you through a few typical deployment timelines. How a few typical timelines look like. The first 2 weeks is about data collection or baseline establishment. The next two would be shadow mode deployment. Uh, this might vary based on the system that you're dealing with, but I'm just giving a nominal value over here. The next following 2 weeks, you'll do a progressive enforcement with careful monitoring. And week 7 plus would be a full production deployment with continuous monitoring. Let's look at some real world results. The results speak for themselves. Let me share your detailed case study. One of the famous e-commerce giant was preparing for their annual flagship sale. They expected traffic spike, but they expected traffic spikes, but were concerned about both security and user experience. During real promotional events, the system was able to handle 740% traffic spikes without downtime and without blocking legitimate users. But the results were much deeper. Higher security, that it proactively blocked multiple DDoS vectors that were trying to hide as legitimate traffic. Increased cost savings by cutting infrastructure cost by 27% by preventing unnecessary scaling because of the attack patterns as they were blocked. Exceptional user experience for customers which maintain 99.95 percentage availability throughout the event. Highly desirable business impact of zero revenue loss due to false positives. This I would like to highlight an experience or incredible experience of a user who has this kind of experience will be a repeat user, thus increasing getting more revenue to the e-commerce giant over here. That's the power of adaptive intelligence in action. This wasn't just theoretical. This is a transformational business outcome. Moving on to the architecture. Now let's talk about security philosophy behind our approach. Security is layered and not linear. The security philosophy does not rely in a binary allow or block mentality. We will look at three important strategies as part of security architecture: progressive throttling, user segmentation, and feedback loop. Talking about progressive throttling technique. The system implements progressive throttling, which creates gentle slowdowns first and then moves to stricter limits, and finally has a hard block only when malicious activity of the end user is actually confirmed. Let me walk you through exactly how this works in practice. How the user stages are tracked and actions are taken. Basically, their users are kept in different stages and what actions are taken based on what stage they are in. User, there is a concept called Risk score. Users are scored using user scoring system based on the risk score. This risk score is from 0 to 100. Every user gets a risk score that updates in real time based on their behavior. So, a risk score between 0 to 30 is considered normal, and the user is allowed given restriction without, sorry, given access with no restriction. The medium risk ones is 31 to 70, means suspicious behavior detected, and high risk ones is 71 to 100 when we have a confirmation that user is acting maliciously, and that is the time that we take action and block the user. Now, how is the risk score calculated? Multiple factors are tracked simultaneously, like factors like request patterns, which can include request burst, timing between the requests, frequency, uh, and then timing of the request as well. Geographic anomalies to identify unusual locations, historical behavior compared to their normal patterns, and more. Let's look at the states. Stage, I told it's called state. It's a state. It is actually stage. Now, I told you about score. That score is what identify what stage the user is. Stage one, which starts with gentle slowdown, which impacts 5 to 10% of the users. The risk score that is for this users is 31 to 50. Users are the ones who show initial suspicious pattern but could be legitimate. Detection system uses things like sudden request burst from normally steady user, or showing some minor geographic anomalies, or some slightly elevated error rates. The result of which is the setup adds 100 to 500 milliseconds random delays to the responses, which normal users can hardly notice. User experience slightly slowed down, but service continues, and the system continues to monitor if user behavior normalizes over next few requests. The score of users the score of users increases or decreases based on the behavior after this as well. So based on which the user can either become a normal user again, which is low risk user, or move to a stage two. Stage two has stricter limits, which involves users of up to 2% to 5% who reach a score of 51 to 70. System identifies these users based on certain suspicious patterns with moderate confidence. Detection system uses things like users show consistent burst behavior, or show multiple geographic jumps in short time, or high error diversity which is nothing but probing different endpoints, and their API usage patterns matches known attack patterns with 70 to 80% confidence. The result of this is that it enforces much lower rate limits and starts returning 429 too many requests with helpful headers, basically telling the user to retry after 60 seconds, or something in those lines. In case the user was a legitimate user, this would be a time that, based on this feedback, the user would course correct and 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 do normal activities. However, if the user ignores these and continues with the request, we can identify that user as a stage 3 user, which starts with the hard blocks which impacts around 0.5 to 1% of the users who have a risk score of above 71. How do we confirm malicious activity of the user with high confidence? Based on if pattern matches known attack signatures with more than 90% confidence. Basically, we compare whether the activity of this users match attack patterns which have been seen in the past. And if we are 90% sure of that, that is when we are sure that this user needs to be blocked. And when the user showcases clear DDoS patterns as well, or credential stuffing behavior used when the end user is trying different kinds of usernames and passwords, and user showcases a consistent malicious activity across multiple dimensions. What is the result of stage 3 when the user is put in stage 3? The result of which is the setup rejects request immediately with 403 forbidden. The setup will also have detailed logging for security team to review based on what all this user did. Another thing this can do is temporary IP blocking for around 24 hours, and one would have to review whether that person can be brought back to as a normal user after analysis of the logs that the team will review. Real-time monitoring and transactions. The system evaluates every user constantly to identify uh, whether the user moves from stage 1 to normal, or moves from stage 1 to stage 2, from stage 2 to stage 1, or from stage 2 to stage 3, or from stage 2, from stage 3 to entirely blocked, who needs to be reviewed. Moving on to the next technique, which is user segmentation. Uh, Here we identify customer tier, enterprise versus free users. Enterprise users get a little more rope or leeway when compared to free users based on their behavior. Historical behavior of the trusted users will be used, like user behavior of someone who forget passwords more often, like me, can be identified based on history and given a little more time before marking it as a credential stuffing attempt. Current context of during business hours versus maintenance windows, showing requests, too many requests coming during maintenance, or slow down when there are not much of traffic, shows kind of a bot attack. This has reduced customer support tickets. This approach of user segmentation has reduced customer support tickets related to API access by over 60%. Now, one of the most important things that we need to do as part of anything that we work is continuous adaptation. One of one of the most important lessons we have learned so far while looking at traditional rate limiting versus latest AI-based rate limiting is that threats evolve, and so must our defenses. For all you know, a setup that worked perfectly today might become obsolete 6 months after now. After 6 months. With continuous retraining and drift detection, the model adjusts to new patterns. The MLOps pipeline includes automated data quality checks to ensure that the trained data remains representative, drift detection alerts when traffic patterns significantly change so that the model can be updated based on the latest data. A/B testing, comparing new model versions against the current production. False positive must be reduced, must um, have been, sorry, false positives actually have been reduced by over 87% by this approach, keeping systems future-proof and cost-efficient. An example of continuous adaptation is when COVID-19 hit. We did see massive shifts in user behavior, like new geographic patterns, different usage times, unusual API sequences. Static systems would have failed catastrophically because of those shifts. This adaptive system learns the new normal within days and maintains security throughout the transition. Now, I know many of you might be thinking, this sounds great, but how do I actually implement this in my organization? Let me give you a detailed step-by-step roadmap. If you're considering AI-driven rate limiting, start small. Here's your six-phase implementation plan. Practical implementation roadmap consists of these phases. Like the first phase is foundation and data detection. Start with your existing API gateway logs. Identify a couple of critical APIs to secure first, like login or payment. Enable basing locking on these APIs if not already done. Collect few attributes. If you do not, you need not do fully fledged 14 attributes. You can start with 7 to 10 attributes and use elk stack or those kind of tools which would help in analyzing this further. The next part is simple analysis and baseline. Use some indexing tools like Splunk or elk stack tools to create dashboards. Dashboards can show things like normal traffic patterns by hour per day, peak usage timings, common error patterns, Establish baseline metrics based on what normal looks like for these 7 to 10 key attributes. So with the baseline done, the next thing that we do is start with rules, not with AI. Because previously we know we had static rules, we can actually have similar rules. Implement smart static rules based on your baseline to identify how these work. Higher limits during working hours versus lower limits during off hours, different thresholds for different type of users, and geographic based rules for unusual locations and activity. Test these rules in monitoring mode rather than on an implementation mode. Collect feedback from the legitimate users. This is where you have got the data, identified your key attributes, identified the value of your key attributes, analyze them, use that to so far create some smart static rules. Moving on to the next part, pilot AI on one API. Choose one low risk API right now at this point of time. Because we are going to use an AI based this, we do not want to impact high uh, important APIs. Use cloud AI services like AWS SageMaker, Azure ML instead of building from the scratch. Start with pre-built models and customize them based on your data. Run a shadow mode. Log decisions but do not enforce. Over here, we are just looking at what kind of decisions are made by the artificial intelligence rate limiter we have in place, and where it is marking users as suspicious or where it's marking the users as not suspicious and all that. Now, enable next step would be control load. So enable AI enforcement on pilot API for 5% of users. Before moving to this step, when we run the previous step in shadow mode, when we log decisions and don't enforce, we want to ensure that the decisions are correct and we are identifying the right users as legitimate users and right users as the fake users. Based on that, only you would go on to the next phase of control rollout. Now, after rolling out to 5% of users, closely monitor for false positives, gradually expand to more users and more APIs, train operation teams on integrating AI decisions or on interpreting AI decisions and also integrating of this kind of rate limiting. Now, talking about last but not the least, the continuous improvement is which is ongoing process. Weekly model reviews and retrain as needed based on the drift, regular feedback loops with customer support teams, quarterly security reviews to adapt to new trends, probably get an understanding of what is out there, what more can you add as part of your AI rate limiting. Each step builds trust and minimizes risk. Don't try to boil the ocean. Start with your most critical APIs and expand from there. Now, the key takeaways that I would like to talk about is uh, first, move from static to adaptive defense strategies. The era of fixed threshold is over. In today's dynamic cloud environments, your security must be as agile as your infrastructure and evolve as per today's your current day's cyber security threats. Second, align throttling with business goals and customer experience. What I mean here is that security shouldn't be a business blocker. It should enable growth while managing risk. Every security decision should consider both technical and business impact. Third, AI-driven rate limiting is proven, scalable, and cost-efficient. We have seen consistent results across multiple industries and scale levels. The technology is mature and ready for enterprise deployment. Fourth, start small scale with confidence. Don't need you don't need a big bang transformation. Follow the roadmap we discussed, and you will build a momentum and demonstrate very quickly the business impact that goes beyond the security, like revenue protection. That means you will this cost that you are spending on cloud will reduce. Uh, or rather, revenue protection is ensuring the legitimate users are not blocked. Cost optimization is ensuring your cloud costs are reduced. Uh, Competitive advantage with users that have better user experience and reliability and ensuring there are more prospects and prospect turns to customers for you. And risk reduction, of course, you reduce the risk of your data exposure, you reduce the risk of your APIs, ensuring all the business runs as usual. I would like to, this is the key takeaways. Thank you for your incredible attention and engagement today. You have been wonderful audience. I I greatly appreciate your time and thank you for attending. Thank you, Uttar Pradesh Power BI Club, for this wonderful opportunity to speak today. Thank you again. You can connect to me on this LinkedIn. There's only one Rahana Sultana Khan. And please do please do subscribe to Power BI Club on YouTube and see you there.
Okay, thank you so much for joining us. It was really an insightful session. I
Thank
personally
you.
enjoyed it too, and it was quite a awareness session as well.
Thank you.
So before I wouldn't take much time as it's 9:30 p.m. in India now. So before ending, I would like to give you the mic again so that you can just share one or two sentences for student or community members apart from this knowledge stuff, just like a random life thing or a key point to remember in life moving ahead forward so that after that we will end it.
Sure. One of the key things that I would like to tell is this is not just about what I told just now. It's always as the world is evolving, as the cyber security threats are evolving, people should evolve as well. When I say people should evolve as well, I need to learn new things. I need to learn new skills, be it physical or otherwise, any skills. Keep growing, and that is when nobody can keep success away from you whatsoever. And if you're talking about BI club members and organizers, I would really like to thank each and every one of you for taking out time and scheduling this kind of talks, giving opportunities to people like me to a platform to come and talk and showcase our skills. That's really awesome. And it's a heartfelt. I would like to thank you from the from deep from the corner of bottom of my heart. I would say, yeah, thank you.
Thank you so much once again for joining us.
Thank you. Yeah. Bye bye.
Okay, I have ended the live stream on YouTube.